Exactly. I mean, any portfolio on this horizontal line has the same desired reward, right? So all I have to do is go to the left. If I go to the left, I'm going to hit a portfolio here that has a lower risk, but it does not have lower return. In fact, if I go slightly southeast, I'm going to have a portfolio. Oh, I'm sorry, slightly to northeast. I'm going to have a portfolio that has higher reward and lower risk. So any portfolio that is inside this line is inefficient. Same thing here. Think of a portfolio right about here that has a minimized risk of 0.70 and reward of 6. Again, I can go to the left without changing the desired reward, but going to left is going to reduce the risk. So any portfolio inside the minimum variance frontier boundary as well as any portfolio on the downward sloping part of, I'm going to call that MVB, is by construction inefficient. Sometimes I find it easier to correct the spelling than actually spelling it right. And think about this portfolio. It's right on the minimum variance boundary. We know anything inside is inefficient, but how about the ones on the line? Well, all I have to do is go northeast, right? Stay on that same line. Going northeast allows me higher reward and lower risk. So as long as you're on this downward sloping part, those portfolios are inefficient. How about these? The upward sloping part. What do you think? And think of different portfolios having different portfolios can be represented by their reward and risk pair. In order to do better, take this one, or let me take this one. Let me make that bigger. Let me add a data callout. For now, I'm just going to call that upward sloping. We'll change it once we talk about it. Okay. Think of that point. What does have to happen if that portfolio is to be dominant? You have to go northeast, right? only Northeast dominates it. I'm sorry. Since I'm left, I dominated Northwest. You have to go up and left. What happens if you go to up and left? Anything up to the up and left or to the left of this line is not feasible. It cannot be achieved. Think about it. Think about a portfolio, possible portfolio here. Let's say 675. Among the portfolios that has a return of 675, the minimum risk that you can achieve is right on this line, right? That's the definition of minimum variance boundary. So nothing is feasible to the left. Portfolios to the left of minimum variance boundary are not feasible. We can actually see that numerically. Let's go back to solver. Where did we put that one? Oh, I need the return data one. Okay. Let's think about this. Let's try to find a portfolio that has a desired reward of 6.5, but I also want to find a portfolio. Let's do 675, 6.5, but I also want to find a portfolio that has a lower risk. So let's see, data, solver. Let me change this a little bit. I want desired return to be, let's find out. This is expected minus desired. I want expected to be greater than 0. So I'm going to change this to greater than 0. And I want to add one more thing. I want the risk to be less than or equal to 0.711, 0.0071. Oh, I'm sorry. I needed something. Yeah, I couldn't find the solution. Okay. Even though it said it's a conversion solution, it couldn't find the solution because that difference is not 0. So it's not feasible. Let's add 2 more lines to this. I'm going to add 9%. First, I'm going to delete that one. I'm going to change that to equal again. Okay, we got it. Let's put 12%. Ideally, I would do it, on a more refined basis, but I just want to get the general idea of the shape. Let's go back to our graph. Instead of redoing the graph, all I have to do is change the numbers. So from until 23, I'm going to go to until 25. That's my new chart. If this is too crowded, always you can make this things reset to auto, or oops, I'm in the wrong place. What's going on here?